I'm both a computer scientist and a forensic scientist. I used to be a professor of forensic science and chemical, biological, radiological, and nuclear related forensics. And so I've mostly been in human health. So where Zach's a young man, I'm an old guy, and I've been doing this for a long time. So I've put over 100 medical products to market in the human space. And I noticed that, of course, in the animal space, there was a severe lack of innovation and bringing these new tools that could be used by the animal health professional as well as by the pet parents or any animal caretaker. Maybe you're somebody who's responsible for cows, dairy cattle or the like. And so my journey really was looking at the number of different problems that needed to be solved to rapid diagnosis, remote diagnosis. It's almost impossible to collect data out of the clinic. And so, how do we solve that? How do we give them clinically actionable data? How do we let the pet parent know that their animal is performing well and they're healthy and the like? And so what I did is I sort of married a couple things from my history. One, I was very fortunate. I was one of 13 scientists appointed to the National Biodefense Science Board, and that was to keep the public safe from chemical, biological, radiological, nuclear threats. Well, part of that is it has to do with animal health. About 7 out of 10 infectious diseases that animals get make a leap to humans, and they get about 70% of our chronic diseases. And then I also was the lead researcher on the U.S. Army Personal Status Monitor, which was to monitor the health of warfighters in theater. And if something happened to them, then how could you triage their health? So sort of married those things, married that sensor technology, that communications technology, that biology or biodefense type of scenario into this one solution where we're looking to predict events before they ever occur. And that way you take the most minimally invasive approach.
We found dog where stories unfold.